Hello guys, this is part 2 of lecture 1. Um, the real number system and scientific notation. So today we're going to talk about ordering of real numbers. As you guys probably know by now, if you go to the right of 0, the numbers are gonna be larger. If you go to the left of 0, the numbers are going to be smaller. So we have our natural numbers and integers displayed on this number line. And then in between these numbers, we're going to find our irrational numbers, right? Like around here, we're going to have the square root of 3. And then a little bit greater than 3, we're going to have our pi. Okay. Maybe around here, we're going to have negative 2.6. Okay. Very basic concept that you should know, but I just wanted to go over it real quick. I apologize if I sound like I have a potato in my mouth. I bit my tongue today, so that's why I sound a little weird. Sound like an Irish guy. Hey, me mama. That was a horrible Irish accent, right? Anyway, let's moving on. So we are going to arrange these numbers in ascending order, okay? So arrange, let's see, let me just type it real quick. Order. And then why is Siri opening? I don't want to use Siri. Sorry about that. We have pi. Let me draw it because yeah, it'll be easier if I draw it. We have pi. We have 3.1. We have 3.1, and then this one is going to be repeating. That's not an I, that's 1, and then the little dot on top. We have 3.5, and then negative 3.1. So if you want to go ahead and pause the video for a moment, so you can arrange these in ascending order. Okay. So how can you go about doing this? Well, you can just rewrite them in a way that you can compare them, right? So pi is about 3.146, right? That's an approximation for pi. This is 3.1. This would be 3.11111. I like to use a line, okay? The paper I have uses a little dot, but I like to use a line to indicate that this number is repeating infinitely. 3.5, this is 3.5. And then this one is just negative 3.1. So I think it's easier if you do it this way. You can see the numbers now, and then you can go ahead and compare them and arrange them in ascending order. So what do I mean by ascending order? From smallest to largest, right? So our smallest number is going to be our negative number, right? Negative 3.1. The next number is going to be 3.1, which is the same as 3.10, 3.10. Next one is going to be this one right here, 3. Right. Next, we're going to have pi. I'm going to write pi here, but these two are the same. This is pi, right? Just to make sure that. And then we got 3.5, 3.5. Okay. Easy, right? So from smallest to largest. Okay. Moving on. Next, I'm looking at my papers here. Exercise number 6. I like this black. Or do you guys prefer, let me know in the comments, do you prefer this hot pink, or this purplish, or red. I'm gonna use this hot pink. One of my ex-girlfriends, she loves hot pink, the color. So let me just use hot, well, not because of her, but I like it. I like it for writing. I like hot pink, and I think it's pronounced magenta. Magenta, right? That's the other color. It's similar to hot pink. Okay, number 6, illustrate on real number lines the numbers x which satisfy each inequality. So let me just type it real quick. So illustrate on real number lines. The numbers, I should make the letters smaller, right? The numbers x, my tongue, I bit it today, eating apples. Numbers x which satisfy each inequality. Let me see if I can make the letters smaller. Too big, right? Format right here. 48. Oh, much better. Yeah, 48 is better, right? Okay. No, redo. Okay. Let's see. We have a x greater than 3. Too much pink, right? Too much pink, I think. Let's use black because black is good. I like black. Okay. So this greater than 3. So we're going to draw our number line. We're going to locate number 3. 0 for reference, and then I have 3 here. And then the numbers that satisfy this inequality are going to be greater than 3. So you can do it on the number line, but I like to draw it right above it, right above the number line. It's my personal preference. I just like the way it looks. So since 3 is not included, I'm going to draw an open circle indicating that this 3 is not included, and then my arrow. No, what am I doing? I have arrows here, right? So I can use an arrow. Yeah, let's see. Boom, nice. I like this whiteboard, digital whiteboard. All right, so all these numbers, 3.5, 3.1, 3.2, all these numbers will satisfy this inequality, right? Okay. B, x is less than or equal to -2. So again, we draw a number line. It's a little crooked. Make it straight. And then we just do, I should do this right here. These little arrows. Let's see, 0, -2, let's see, -2 here. So the x values are going to be less than or equal to -2. So now my -2 is included, right? So I can fill it in. You fill in the circle. If it's not included, you leave it empty or blank. And my tongue. And then it says less than, so it's going to be going to the left. So let's see, we start from here and then these values. Good. And that's it, right? This is how you represent these inequalities, the solution for these inequalities on a number line. Let me do one more. C. We have -1. X is greater than -1, but less than or equal to 2, and less than or equal to 2. So we do our line, chabaduo, and then our arrows, ugly arrows. No. Oh, maybe I can use the same. Yeah, right. The other feature. Okay. So let's see. Let's find our values. 0, -1, -2, 1, 2, and it says x is greater than -1, so it's not included, right? Let me erase this because I don't want to confuse you. And then less than or equal to 2, so 2 is included, right? And that's it. The values between these two numbers will be part of the solution. Okay? That's it. This is how you represent these solutions on a number line for inequalities. Okay? Cool. Moving on. Yeah, -1 less than or equal to, yeah. If I make any mistakes, I can't pronounce. Just make sure you drop them in the comment section. I'm following my notes, and I should be doing everything right, but I'm still getting used to the digital whiteboard. I'm still getting used to this tablet, drawing tablet. So yeah, I might overlook something. Like in my previous video, I wrote rational. It was this. Let me just write it real quick. We had an example. I think it was 2 divided by the square root of 3, and I wrote is a rational. I wrote this, but I said is a rational number. So I should have written number, but I did not write the word number. Anyway, minor mistakes. Just be aware if I make them is because I'm still getting used to the whiteboard, the drawing tablets, and just recording my lectures. But if I don't practice, I'm not gonna become better at doing this. So I have to do it. I have to start doing it. And it's good reference. I can keep all of this and go back to it and use it, right? Even use it in my classes. Okay, moving on. Terms in mathematics. Terms in math. So let's see. We got even. Numbers that are divisible by 2, right? Divisible by 2. We got odd. Numbers which are not divisible by 2. Not divisible by divisible by 2. Prime numbers. Numbers which have exactly 2 factors. Exactly 2 factors. For example, number 2, right? What are the factors of 2? 2 times 1. That's it. You cannot, 2 doesn't have any other factors, right? What about 3? 3 times 1. What about 5? 5 times 1, right? So these are prime numbers. Now 2 is also even, right? 2 is prime and it's even. So you got to be careful with that. You cannot think of 2, you cannot think of prime as being odd. You have to think of prime like this, only 2 factors, the number itself and 1. You might be thinking of 9 and saying, oh, 9 is a prime number. No, it's not, because you may be thinking it's an odd number. But 9 has these factors, 3 times 3, right? 9, also 9 times 1. So it's got more factors. If it only had these two, 9 and 1, yes, it would be prime. But since it's got 3 as, my tongue, 3 as factors, then it's not prime, okay? So 9 is not prime. It is odd though. 9 is odd, but it's not prime. Okay, so keep this in mind, and we also have composite numbers. Okay. Why is it composite numbers? Um, these have more than two factors, okay? These have more than two factors. Let me just write it. Let me type it out. Because if I write the number 2, it might confuse you. Then 2 factors. So examples are 4, right? 6, 8, 9, 10. Okay. So we have even, odd, prime, and composite. Okay. All right. Let's get into some exercises. Exercise 7. Find the sum of 6 and 12. Okay. Let's see. So remember from our pre-foundation classes, sum indicates what? Addition, right? Sum. So this is just 6 plus 12 equals 18, right? B, find the product of 6 and negative 2. Let's see. Product means what? Multiplication, right? So we're just going to multiply 6 times negative 2, and this is negative 12, right? But remember the keywords that we went over before: sum, product, difference, quotient, etc. All right, C, find the difference of 16 and 26. Okay, so for the difference of 16 and 26, our 16 is going to come first, and we are subtracting, right? And this will give us negative 10, right? All right, let's do one more. Find the quotient of 12 and 6. Uh, 12 and 6. So we're taking quotient means division, right? So we have to take 12 divided by 6, and that's 2, right? That's it. So if you have the paper, I want you to do E and F. So do E and F. The reciprocal of this, so E is, find this, 2 3/4, and F, find the prime numbers between 20 and 30, okay? Prime numbers between 20 and 30. Okay, now we're going to get into scientific notation. So let's see, scientific notation here. Scientific notation. Pretty simple concept, right? I'm pretty sure many of you have seen this before. This may be a review. So we have to write it as a product. Product means multiplication, right? Of a number between 1 and 10. So let's see. So it could be the A. That could be our number, right? A is going to be between 1 and 10. And a power of 10. Where P is going to be our exponent for our power. Okay? So when you write it, it's going to look like this. A times 10 to the P. And P could be positive or negative. And in case you forgot, remember that we use scientific notation to express very small numbers or very big numbers, right? And if you want to write it in a more compact way, we can have A would be greater than or equal to 1 and less than 10, right? And like I pointed out here, P is going to be positive or negative. We're going to see how this works. If we have a positive P, what we need to do. If we have a negative P, what we need to do. For many of you, this is a review. For some of you, if you're not in my class, you maybe this may be something new for you. Let's see. So for large numbers, the power of 10 is going to be positive. So P is going to be greater than 0 for large numbers. For example, 45,000. How can I write that in a more compact way? Well, I use scientific notation, and that's going to be 4.5 times 10 to the fourth power. And how do I figure this out? I have my decimal point here. Let me show you. This is a good way to visualize it. This is my decimal point, right? 45,000 decimal point here. So if I want to write it as 4.5, I need to move the decimal. So I check to see how many decimal places do I have to move it to have a number between 1 and 10. So 1, 2, 3. Is 45 between 1 and 10? No, it's not, right? So I need to move it one more. So 4. So 1, 2, 3, 4 places. 4.5 is between 1 and 10. And that's why I wrote 4.5. And then my P is going to have the number of places I moved my decimal place, my decimal point. 1, 2, 3, 4. So that's going to be my power, my number for P. Okay. Now for small numbers, small numbers. This means number. So just a quick way to write numbers. If I add an S, it means numbers. So I have this number, this very small number here. And I want to write it in scientific notation. So I have to move the decimal place enough to be able to make a number between 1 and 10. So let's see if I'm here, if I move it 1, 2, 3, 4. So now I have 3.29. And then remember, the number of places that you move to decimal place is going to be your exponent. So 1, 2, 3, 4, right? 1, 2, 3, 4. But in this case, remember, p is negative, so we have to use -4. Okay, not +4, -4. If we use +4, we're moving this to the right, 4 places to the right. So we would have this plus 2 zeros, right? 3.29, and then 2 more zeros. And that'll be started with here at 3.29, and we move it 1, 2, 3, 4. And that's not the number we had. You see, these two numbers are not the same. Okay, so that's why it has to be negative. Okay, for small numbers, negative power of 10. For big numbers, positive. Okay, we'll just write it for my notes. Okay. Let's practice. Exercise 8. Express each of the following in standard form. Standard form means in the number between 1 and 10 and the power of 10. So we have A, 274,000. So remember, the decimal point is going to be here. So we have to move it, right? We have to move it to the left. How many places do I have to move it to make a number between, to get a number, to get my A to be between 1 and 10? Okay, good. So the point is here, the decimal point is here. I move it 1, 2, 3, 4, 5. So this is going to become 2.74 times 10 to the fifth power, or 5. B, we got 30. This is easy, right? 3 times 10 to the first power. C, we got 0.00092. So again, we got to move it now to the right. So 1, 2, 1, 2, 3, 4. 9.2 times 10 to the -4. All right. Now we're going to go the other way. We're going to go from standard form to ordinary numeral. Numeral is a number, ordinary. We're going to go back to ordinary numeral. So let's see, we have let's see, D 2.5 times 10 to the 6. Remember, this decimal point, since this is positive, is going to go to the right. This is a big number, right? So we're going to move it one place, and then we add zeros, right? So we move it one place, and then we got to add 5 zeros. 1, 2, 3, 4, 5. And then we just count 3. That's it, right? 2,500,000. E, 4.1 times 10 to the -1. Now this is a negative P, so we have to move to the left, right? And then, so it's here, and we're just gonna move one place to the left, right? Because it's just one, -1, one place to the left. So that's gonna be, it's gonna become 0.41, right? That's it. You can write a 0 here if you want, but it's not necessary. Sometimes I like to write it. Lastly, F, 7.02 times 10 to the -3. So again, now it's negative, so we got to move to the left. is here. We got to move it 3 places to the left. So it's going to be 1 for the 7, and then we add 2 zeros, right? So 7, 0, 0. And then our number becomes this 0.00. Oh, come on. 0.00702. 0.00702. Okay? Okay. The calculator, okay, using the calculator. And this is our last section for this video. Using your calculator. So they might ask you to do provide the answer correct to decimal places, correct to significant figures, to the nearest integer, to the nearest hundredth, to the nearest hundred, and so on. So I'm going to show you how to do that. If we have this number here, and that's going to be the cube root of 4,530. And I want you to write it correct to 3 significant figures, okay? To 3 significant figures. So remember from our previous lectures, significant figures, how do you calculate them? You start counting from left to right, and you start counting from the first non-zero numbers. And then you count the number of significant figures asked. In this case, we got 3. And then you count 3 numbers, and you look at the third number, and then the number right next to that third number, if it's 5 or greater than 5, you add 1 to the third number. If it's less than 5, you just leave it the way it is and write the other numbers as 0. My tongue. So for this number, we get, let me do it real quick, 4530 to the 1 divided by 3. And this is 16.5462. So again, we start from left to right from the non-zero numbers. So this is our first non-zero numbers, zero number, 1. So we count 3 from there. 1, 2, 1, 2, 3. So that'll be to 3 significant figures up to that 5. We look at the number right next to the 5. It's a 4. So we don't change the 5, right? And then we just write it with 3 significant figures. That's it. Okay, you can write a 0 here if you want. It doesn't make a difference. It's the same, right? If this number was 5 or greater than 0, then you need to add 1 to 5, right? But that wasn't the case. Okay, let's see. B, we have, let's see. (0.052 to the 4th power. In scientific notation, correct to 3 significant figures. Okay, this, let me just write it. In scientific notation, correct to 3 significant figures. So what you want to do is you want to first multiply this out with your calculator. So 0.052 to the 4th power, and we get a very small number. Point, how many zeros? 1, 2, 3, 5 zeros. 1, 2, 3, 4, 5 zeros, and then 7, 3, 1, 1, 6, 1, 6. And now correct to three significant figures. So we want to get it in three. We want to write it correct to three significant figures, and then we want to do it as a scientific notation. Okay. So we start from left to right, from the first non-zero numbers, and that's our 7. And then you count 3 numbers: 1, 2, 3. All right, 7, 7, 3, 1. We look at the number right next to the 1, and it's also a 1, so we don't change the 1. So these 2 3 significant figures would be 1, 1, 2, 1, 2, 3, 4, 5, and then 7, 3, 1, right? And that's it. This is this number to 3 significant figures. Now, they're also asking for the number in scientific notation. So now we have to move this decimal place to the right. And how many places do we have to move it until we make a number between 1 and 10? Let's see. 1, 2, 3, 4, 5, 6, right? 7.31. So this would be 7.31 times 1, 2, 3, 4, 5, 6, 10 to the negative 6. All right. Lastly, all right, if you're following my class, I want you to try C and D. Again, this is very simple. These are very simple exercises. C correct to the nearest integer. 32,995 divided by 35.9 times 0.017. Correct to the nearest integer, okay? To the nearest integer. And for D, this correct to 3 decimal places. To 3 decimal places. And the number is, no, I like the other one. It's a little thicker, right? Number is 2.46 times 10 to the third power times 9.3 times 10 to the negative 5th. So correct to 3 decimal places. If you're watching this video and you're not in my class, go ahead and do it and drop the answer that you got in the comment section, and I can get back to you if you're not sure about the answer, okay? So again, this one corrected 3 decimal places. And then let me just make sure that I got the right stuff. 2.46 times 10 to the third power times 9.3 times 10 to the 5th power, negative 5th, negative 5. And C, and this one to the nearest integer, okay? 32,995 divided by 35.9 times 0.017. All right, and this is part 2 of lecture number 1, the real number system and scientific notation. Thank you very much for watching my video. And if you liked it, give it a thumbs up. If I made any mistakes, make sure to mention them in the comment section. Again, I'm juggling papers, tablets, whiteboard, and I'm still getting used to all of this. So yeah, if you're one of my students and you have any questions, send me a message on WeChat. All right, thank you very much for watching. And this was Speaking Math with Mr. Campo. Bye-bye, take care.